Today I'm going to introduce a few of the applications of the standard deviation that get us beyond just simply knowing the variation in the data set. So it'll give some more meaning to the data set and to the data points within the data set. Once again, the standard deviation is a measure of the average difference between the data that are in a data set and the data set's mean. So it's a really nice measure of how spread out the data are from the mean and also how spread out they are from each other. It's a measure of how different people are from each other. Okay. So that's very useful. However, we can also apply it to some new things to understand more about the characteristics of the data set, and we can give more meaning to individual scores, for example, which we're going to start to introduce today, and then we'll get into more in the next presentation. So first we need to understand some facts about the standard deviation and what it tells us about a data set's shape. All right. There are some rare circumstances where this is not true. For example, a very skewed distribution. It could also be something that has two or three modes, for example, and now kind of all bets are off. But if you have a mound-shaped distribution that's roughly symmetrical, then just above 68% of all data points in that distribution fall within one standard deviation. So it looks basically like this. If this were a group of people, a large group of people, and a measure of IQ, it turns out that almost everybody has within one standard deviation of the mean IQ. And one thing that we know about IQ is that the mean is 100. It's actually an arbitrary measure, but it's just set at 100 is what we call the mean. And then we call the standard deviation 15 points beyond. So in other words, everybody, out of everybody, 68% of everybody has an IQ somewhere between 85 and 115, or roughly, I guess it'd be, yeah, that's fine, 86 to 114. Okay, so that's very interesting. Now, to go beyond that just a little bit, 95% of everybody has an IQ score within two standard deviations of the mean. So these little lines here along the x-axis indicate these standard deviations, right? So one standard deviation is 15 points. This would be 30 points above the mean, as you can see here, okay? And 95% of everybody has an IQ between two standard deviations below or above the mean. In other words, everybody's got an IQ, 95% of people have an IQ between 70 and 130. Okay. Now, by the same metric, of course, or in the same line of thinking, 99%, just above 99% of all people have a score within three standard deviations of the mean in again, a normal distribution, a normal bell-shaped curve. Now, this doesn't have to be IQ, right? This could be essentially any variable that is relatively normally distributed, or at least symmetrical. That's the way the math works. The math has to be that way, and that's a very important property that's enormously useful, as we'll get into. So let's continue on with this. So once again, if we know that the mean IQ score is 100 and the standard deviation is 15, then I know that everybody, or 68% of people, just above 68% of people, have a score between 85 and 115, right? I said that earlier. However, maybe we can get some more meaning for that, right? Let's see if we can apply a little bit more meaning to this. Now, if you think logically, if this is a symmetrical distribution, then half of the sample, or half of the population in this case would be fine, has to fall below the mean, and then half of the population has to fall above the mean, right? So 50% of people have an IQ below 100, or I suppose that you would have to include 100 at some point, right? And half of the people have an IQ above 100, if you also sort of include 100, right? So that's very useful, because now I can use that information to understand people who fall not on the mean, and I can give you what is called a percentile. I can know where in relation to the rest of the population you fall. And I'll give you an example of that. Could we figure this out, for example, with a score of 115, knowing what we know about a standard deviation? Well, this may seem logical, but I'll walk you through it anyway. So if we know that 68 and a little bit more percent of all people fall within one standard deviation of the mean, what that means is that we can divide that 68% in half and get just a little bit above 34% fall within 1 standard deviation above the mean, and 34% fall within 1 standard deviation below the mean. So if I'm interested in figuring out what percentile a score of 115 is in, what I need to do is take the 50% that falls below the mean, and then I needed to know this section. I needed to know how many people fall within just that proportion. And as you can see, it's just above 34%. So therefore, it's a fairly simple bit of math to just add the 50% to the 34%, which is right here. 50% plus 34%, of course, gives us 84%. So in other words, if somebody tells me I've got an IQ of 115, I can do this simple math and say, that means you're in the 84th percentile, like this. So if you're in the 84th percentile, that means essentially this, that your score of 115 is higher than 83% of the population. You're in the 84th percentile. I suppose who you're talking to might say it is higher than 84% of the population. We're rounding just a little bit, which is fine. Okay, so that means essentially that means if you were to walk by, if this person with a score of 115 were to walk by 100 people who were random, that's important, but walk by 100 random people, our best guess is that they would have a higher score than 83 of those 100 people that they walked by, okay? Unless there's something else going on, something anomalous going on. And that's interesting information, right? So in other words, you could come into me and say, hey, I have a score of 115. And I could say, well, that's pretty high because the average one is 100, right? That gives you some meaning to the data, but that just tells you you're above the average. But now if I can tell you, wow, you're in the 83rd or 84th percentile, that adds some more meaning to that score. That also, the opposite is true because the distribution of IQ is essentially symmetrical. If you're 1 standard deviation below, in other words, you have an IQ score of 85, that means that you are less intelligent than 83% of the population. So a couple of things that we can know here. 1 standard deviation is actually pretty big. It's not enormous, but it's pretty big because 83% of the population falls below 1 standard deviation above the mean. So most people fall below 1 standard deviation above the mean. That's pretty interesting, and that's big. This is a very important principle that we'll continue to talk about throughout all of statistics, because these principles in z-score and unlikelihood in the tails of a distribution become very important, especially in interpreting future statistical tests. So I'm just introducing the basic concept here. The beauty of this is it gives us more meaning to a single score. Not only do I know you're above the mean, for example, I know what percentile you're in and how you fit into your specific distribution. We can also use this information for something a little bit beyond this, where we calculate a z-score. Now, we'll continue that next time. I don't want to throw too much at you in one particular lecture. So we'll continue with that next time, and I'll see you then. Thank you very much.